before our final. And we're going to look at some questions on our practice final, our take-home final. So we're going to look at question 4 from our take-home final. I'm not going to work it out completely. I'll only work it out about halfway. Now, question 4. We have a circle that has a diameter. Now, we want the radius. Okay? Now, there are 2 ways to do this. We can either find our center and then use the center with one of these points, which I think is what I did in the key, or you can just use these 2 points with the distance formula and half it to get the radius. Because it gives you the diameter, we want the radius. So I'm just going to use these 2 points, find our distance formula, and then half it. Okay, so let's make sure we know what to do here. So they give you the 2 points. Now the key word there is diameter. So we've got this point -2, +1, and we've got 4, 9. Now let's go ahead and set up our distance formula. So the distance equals the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. This is x1, y1, and this is x2, y2. So we fill it in. I'm not going to work it out much past this, but I'll at least put the numbers in and show you what to do. I think when I worked out in the answer key for the practice exam, I think I found the center first and then used it with one of the points. But this is the same answer. Okay, and this is going to give us our diameter here. So this is our diameter. And when we find that diameter, we want the radius. And radius is going to be the diameter over 2. So what will you need to do? Okay, you're going to have to finish this out here, break it down, and then whatever you get is not your answer, right? That's going to be your diameter. How do we get the radius? Whatever we get, we take it and we do what? Half it. You can also find the center by using the midpoint formula, and then use the center with either of those points and get the same answer. Either way. So either calculate the diameter and half it, or use the center with one of the points to get the radius itself. But either way, you want that radius. Is everyone all right with how that one works? Okay, that's an easy question, but I see students miss that one off. Do I need to move the TV, or can you see it? Do what? Okay, just want to make sure. But that's what you'll be doing on that one. So there's going to be a question on your exam that is just like this. Right? Different numbers. It might be question 8 instead of 4, but it will be there. Okay, so that was question 4. Now you will have 30 questions on your exam, so I'm going to get rid of 10 of them, but chances are this one will be on there. The next one that I'm going to have you look at, or that we asked about, was question 15. This one I see students miss a lot. This is one of the most commonly missed questions on the final. The students who took it early, and I've given the same final over years, just different numbers. This is a very commonly missed question. The most commonly missed one. Now, we covered this. And how do we work this one out? Where do we begin? Well, we have to think about what we've got, right? We've got exponents, okay? Now, where's our x at? X is an exponent, right? So how can I get the x and get it to where I can solve it? Well, remember, with these exponents, either the bases have to be the same or the exponents must be the same. Now, our variable is an exponent, so we're going to want to try to make sure that our bases are the same. Now, when we look at 8 and 32, they're not direct powers of each other. If this would have been a 4 and a 16, it would be an easier question, right? This one's a little bit different. We need to figure out what they have in common and how we can work this out. Well, what do we know about 32 and 8? They're both even numbers. So they're both factors of 2. So we're going to try and get the bases to be the same. Now, what do we know about 8? Well, we know that 8 is 2 to the third power, right? Because 2 squared is 4. 2 cubed is 8. Is everyone okay with that? Now, what do we know about 32? Right, let's try to get the same base. 32 is equal to 2 to the what power? Well, let's try it and see. Okay, 2 squared is 4. That doesn't work, right? 2 to the third power is 8. Doesn't work. 2 to the fourth power is going to be 16, right? Doesn't work. But what about 2 to the fifth power? Well, 2 to the fifth power is what? 32. So now we have them, and they have the same base of 2. So I'm going to rewrite it, and then I'm going to leave the rest of it for you to finish. So 32, I'm going to rewrite that as 2 to the fifth power. Now, whatever's up here has to be multiplied by that 5. So it's 2 to the fifth, and then we have to multiply that 5 by x minus 1. Now, what about the 8? Well, we know 8 is 2 cubed, so that's going to be 2 to the third power. And what else is up there? A 4x. Are the bases the same? Yes. So I'm going to do one more step, and then I'm going to let you finish it. So what's my equation going to look like? It's going to look like 5 times x minus 1 equals 3 times that 4x, and you can finish that now. There's one on your final exam that looks very, very similar to it. I usually try to keep this question, but does everyone see how we get the same base? It might be different numbers. Instead of a 32 and an 8, it might be a 32 and a 64 or something like that. But it's going to be a similar question. If the base is the same, then you can solve that resulting equation. Is everyone okay with that? Make sure we understand that one. That was a commonly missed one. We've got a couple more to look at. I picked question 24 because a lot of times students miss this one. Okay, so we want to graph this one. This is our directions here. We want to graph it. Now, what do we need to do with that square? That square needs to be what? Distributed through. Okay? So it's not just 4 that makes it a what? 4 squared, that's a 16x squared. Now, what is this going to look like? It's going to look like this. Looks like f of x equals x squared. And remember, whenever we have a square, that is a u. Now, yours might be an absolute value, or it might be a cube or something like that. But remember, if it's a square, it's a u. If it's a cube, it looks like that. Absolute values make a v. I'm not going to finish this completely out, but where are we going to start at? Can anyone tell me where I would begin at? What's my lowest or highest point, the vertex? Okay, where would I start at? What would this point right here be? It's going to be at what? Does anyone know? If I was going to graph it, am I moving this up or down any? No. Am I moving this graph left or right any? No. So where would I start at? 0, comma what? 0, 0, right? Remember that? Is it going to go up or is it going to go down? Which way? It's going to go up, right? Why is it going to go up? Because of the 16. And what are you going to use? You're going to use 16 over 1, so you're going to have to go up 16 and over 1. So that's going to make this a very, very narrow graph, and I'm going to let you finish it. But where do students make a mistake at? They forget to square the 4. And they say you go up 4 and over 1. And then it's too wide. This is going to be a very, very narrow graph. It's going to be really, really tight there. Okay, because you're going to go up 16 and over 1. So it's going to be a very, very shallow graph. And it's going to look like a U. Why does it look like a U? Because it is what? It is squared, right? Is everyone okay with that one? That's a commonly missed one because students forget to square here. If you went up 4 and over 1, I'd probably take a couple of points off. So you need to make sure you go up 16 and over 1. Sure, yep, we can add 22 to the list as well. And we've got plenty of time. So any of these you want me to work out and get you started on, I can. Also 23? Sure. Very, very important that we do well on our final, because our final is worth a lot of points. It's worth 300 points, but students do well. All right? Don't worry about it so much. It's just making sure we understand the concepts. They're not really difficult questions. A lot of these are 1 or 2 step problems just to make sure you understand the basics, because that's what this is. It's a comprehensive final, and it's just making sure you know things like, how do I graph a basic square? How do I find the center and radius of a circle? Simple concepts, not try to solve a big, huge question. Okay, so let's add, we added 22 to the list, so we'll look at 22 next then. And 22, we're going to use the quadratic formula. Okay, we're going to try to use the quadratic formula here. Now, I'm going to set it up, and I'm going to work about halfway through it, and I'm going to leave the rest of it for you to finish. Okay, so I'll get to the point where we have the numbers in the quadratic formula, but you're going to have to break down and evaluate the roots. So what's our quadratic formula look like? Well, it needs to look like this. To use the quadratic formula, it needs to look like this. ax squared plus bx plus c equals 0. Well, is ours in that form already? Yes. Now, if this 34 would have been on the other side, what would we do? Bring it over. Okay, but ours is there. If there's no number in front of the x squared, what do we add on? We add in the 1. So this is your a, this is your b. And so there's your a, there's your b, and this is your c. Now, what does your quadratic formula look like? This is something you can either memorize or put in your notes. Because remember, you can have a page of notes. So what does the quadratic formula look like? Well, it looks like x equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, we've got all the pieces labeled, so let's go ahead and write them out. A is 1. B is a negative 10. And C is 34. I'm going to go ahead and plug the values in. Now, where's the most commonly made mistake? The most commonly made mistake is right here. This and the roots. Improperly breaking up the roots is the other commonly made mistake. This is the most commonly made mistake, is a double sign here, the double negative. So we have a negative of a negative 10. And we'll deal with that in a moment. And then we've got plus or minus b squared, which is a negative 10 squared, minus 4 times a, which is 1, c, which is 34, and that is all over 2 times 1. Okay, is everyone all right with how I plug the numbers in? If not, make sure you say something. I'll do one more step, and I'll let you break it all down. Okay, so let's do one more step. Now, how do we handle it from here? What do? We work with our discriminant first. And what is our discriminant? Well, it's whatever's underneath that root. And it's a minus 10 squared minus 4 times 1 times 34. And, okay, what happens when we square a negative 10? Watch your signs. Be very careful. If there's a mistake, it's either up here with the double negative or it's here with the signs. When we square negative 10, it becomes a what? Positive 100. Okay? And then we've got a minus 34. A minus 4 times 34. That makes it a minus 136. We put those together and we get a minus 36. So I'm going to rewrite it, and I'm going to leave the rest of it for you to do. So the double negative here makes that positive. So that is a positive 10 plus or minus the square root of a minus 36 over 2. Now you can finish it from here. But let's talk about the answer. The answer is not going to be a real number, is it? And you're going to get 2 of them. Why do we get 2 of them? Because of the plus or minus. Now, what about that square root of that negative 36? Well, it's a negative underneath the root, so what's going to come out with it? An I. Okay? So you're going to have 2 answers, and you're going to have an I involved. Plus or minus makes up 2. So break it up, reduce it down, and get your 2 solutions there. You can either write it as 2 or keep the plus or minus. I'll take either one. But it's going to have an I because of this. And I don't want to do it all because I want to leave some of it for you to do. Because it's the take-home final is just practice to get you ready for the real one. So that hopefully now helps with question 22. Is everyone okay with that? Don't ever hesitate to ask questions because I want us to do well in this final. It's very, very important. I want us all to be successful, and I think we will be. Question 23. Okay. Question 23 is a graphing one, and I keep this one on the final as well. I'll do one of them. You do the other one. This is what's called a piecewise defined function. And a piecewise defined function is done on different levels. And when we work with piecewise defined functions, we need to make sure that we understand that it's either going to have an open circle or a closed circle. And what's the difference? Strictly less than, strictly greater than, those are going to get an open circle. Greater than or equal to, less than or equal to, well, those get what? The closed circle. So the top one, it's going to get an open circle, and the second one, it's going to get a what? Closed circle. So that's the first thing that we do. Now, I'm going to do the first one. You can do the second one. So I'll do half of it. I don't want to do it all, because I want you to have to do something. Otherwise, you just copy it down, and you won't know how to do it on the final. Okay, so I'm going to do the first one. And we need to look and see what this is saying. So we're going to do the first row here. row number 1. And that is 2x plus 4 with x being less than 0. Now we know when we graph it, it has to have an open circle. And if it says if x is less than 0, now we need 2 points. Okay, x has got to be less than 0. So I'm going to use then x equals 0, because we always plug the value in. You always plug that part in. And we need another number, but my number needs to be what? Less than 0. Okay, so what am I going to use? How about we use a -1? Plug that -1 in to both of these. But not both of them, but the first one. And plug the 0 into there as well. So let's plug in the 0 for the x. And that's a 2 times 0 plus 4. 2 times 0 is 0. That gives you a 4. That is your y value. So we have a point now at 0, 4. Now we needed another point because you need 2 points to connect these together. We're going to plug in a -1. If I plug in the -1, what does that give you? That gives you 2 times a -1 plus 4. And so that's minus 2 plus 4. So that gives you y equals now 2. So as an ordered pair, it would be -1, comma 2. Now, what about the second row? I'm not going to do it for you, okay, but what would you use for the values? Just so we know, we would do the second row the same way. I would start on the second row by plugging in 0 and evaluating it down. Now, for the second row, you need a number that is what? That is bigger than 0. So what would I use? Well, I would say use, how about 1? Well, you could use 2. It doesn't matter. But I would say use 1 or 2, plug it in, get your second point, and then connect them together. Now, these are separate pieces. They're separate graphs. So I'm only going to do the first one. You're going to have to do the other one. When I go to graph this first one, it's going to be a line. Okay, and where do we start at? We start at 0, 4. And we always start in this case with an open circle. And where's my next point? -1. So that's back 1, up 2. And I'm going to connect these together. And there is half the graph. So this is only half. You've got to finish it. And this is only half. So that means we have to do row 2. So I'll just say work out row 2 with x equals 0, and we'll use x equals 1. You get your ordered pairs. Now I will tell you that it's going to be a curve like this. It's going to look something similar to that, but you've got to work it out and see. So that's what you'll need to do to finish this. It's only half worked out. You're going to, okay, so it's half worked, so we need to finish out row number 2. You're going to use row number 2. You're going to plug in 0 and 1, and it's going to have a closed circle wherever you start, and to connect them together with a little bit of a curve because it's squared. So that's half of it. That was question 23, right? So now we're going to move on to question 36, I believe, unless we have some more. If we don't have any others, we're going to look then at 36. And we can add more to the list if we need to. If we finish early, we finish early because this is our last class period. But I want to make sure we do well. So 36. On 36, I can't partly work this one out. I've got to completely work it out so you see what the answer is. And we're going to go through this one, and we're going to use process of elimination. So when we look at this, let's think about first what we've got. We've got a mat here, and it's got a border around it. And it says the mat around the picture shown is X inches across. Which of the following equations says the area itself is 700 square inches? So first off, we see this 700. So what does that mean? That means it should equal 700. So can we eliminate any of them yet? No, because they all equal 700. Now we need to figure out how we can dimension this out. What do we know about this part here? Well, we know it's X across. So let's look at and see what we've got. Okay, we want the area of the picture itself. So the inside, we're going to look at the inside. This is going to be the inside here. So that's this piece right here. We look at the inside, and we need to redimension it. Okay, now here's where sometimes students make a mistake. This is 31 tall, but what's got to be gone from it? It's not just X, it's a minus 2X. Why is it minus 2X? Because you have a top and you have a bottom, right? And what about the one down below? It's 45, right, left to right. And how much is gone from it? It's not just X, it's a what? Minus 2X. Now, which ones can we start eliminating? Which ones can we get rid of? When we put these together, what's it going to look like? It's going to look like this. The area is going to be 31 minus 2X and 45 minus 2X, and that equals 700. So which ones do we need to get rid of? Which ones are going to be? We got to get rid of A because A doesn't make sense at all. Right? It's not what we want. That's not it. What about B? Okay. Why does B not work? Because B would be the mistake that students sometimes make because it's not just taking off X, it's taking off what? 2X. So don't fall into that trap. It's got to be minus 2 because you have a left and a right, a top and a bottom. So B is gone. C just doesn't look right at all, does it? Because the 2's. I don't know why they just put the 2 in front. That doesn't make sense. So what does it have to be? It has to be answer what? D. Is everyone okay with how I did that and why that is the correct solution? You don't have to work it out. All they want you to do is figure out what equation this came from. And there was no way to really do it without working it out completely. We also ask about 37. And 37 is the distance formula. So we did the 36, we just did that one. So we're going to look now at 37. And I'm going to work this one about halfway out. So they give you the two ordered pairs. They give you minus 3, minus 5. And then you've got a Q, which is 1, comma, negative 3. And we want to find the distance. That's what we're doing here. So what's our distance formula? Well, your distance is going to equal the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. We plug our values in. And I'll work this one again about halfway out. And I'll leave most of it for you to do. I'm going to plug the numbers in and probably square them, and then you can finish it from there. Now, where's the most commonly made mistakes? Double negatives. Students usually can get the right formula, find the right values, but where do we make the mistake? Double negatives is the most commonly made one. Or incorrect breaking down the roots. But more common is sign errors. So let's plug in our values, and we have a minus 3. Watch it. It's not these two subtracted. It's the x value, 1, minus the second x value. So that's a minus 1, right? It's those two subtracted, squared. Then we've got our y's, which is minus 5. Watch out for double negative, minus a minus 3. Minus 3 minus 1, that makes it a minus 4 squared. Double negative makes this a positive, and we've got minus 5 plus 3. So minus 5 plus 3, that makes it a minus 2 squared. I think you can finish it from there, can't you? Now, how do you know if you made a mistake? If you get a negative number underneath this square root, you know you made a mistake. Because when you square a negative, what should it become? Positive. When you take a distance, can a distance ever be an imaginary number? No. If you got a negative left under here, you made a mistake. Because everything should be positive when you square it. So if you end up with a negative underneath this root at all, you made a mistake. Because think about what it is. It is a distance, and distance cannot be an imaginary number. So you'll put those together, and you'll break it down. It'll be the square root of 20, and you've got to break down the square root of 20. And question 39, this is a question that I just have to work out because there's no way to really explain it without completing it. This, again, like many of the others, is a concept question. Okay, we want to find the slope. Yeah, because we asked about 39, didn't we? Yep, 39. Okay. We want to talk about the slope of this line. Okay, so this is what we've got here. The one on your exam may be different. It might be a vertical line instead of a horizontal. So when I look at this one, it's a horizontal line. Now let's talk about the 4 kinds of slopes. A diagonal line, like this. This one has a negative slope because it's going down from left to right. This one would have a positive slope. Why? Because you're going up from left to right. Let's remember the one that we've got here. This one is a horizontal line, and its slope is what? 0. And the opposite is a vertical line, and what would its slope be? Undefined. Okay. And I may give you a vertical line instead of a horizontal one on your final. I like to do things like that, change it up a little bit. But this is just making sure that you understand the very, very basics of slope. So this line is a horizontal line. So what would its slope be? What do you think its slope would be? Its slope is going to be 0, isn't it? And that's what I want. Now, if I gave you a vertical line, what would it be? Undefined. Don't miss this question. This is an easy question. There are a lot of these on here like this. Questions that don't have a lot to really work through and calculate. They're making sure you understand basic fundamental concepts. Horizontal lines have a slope of 0. Vertical lines are undefined. Diagonal lines, if they go up, they're positive. If they go down, they're negative. Basic concepts. Not even calculation at all. It's just looking at it and understanding the basics. Did we have any other questions to look at? That was 39. Did we have any others to look at? Anything else? 30 and 31? Yep, we can add those to the list as well. 30 and 31. Okay, so let's add those to the list here. So 30 and 31. We covered these about a week ago when we talked about systems of equations. Now, I don't care how you solve these. You can use elimination. You can use Cramer's rule. You can use substitution. I don't care how you solve them. The easiest way is probably going to be elimination. You can use Cramer's rule if you would prefer. Substitution would be the hardest. You can use either Gauss-Jordan, you can use elimination, those are basically the same, or you can use Cramer's rule. I would probably recommend elimination just because it's the easiest and it's the one that you're least likely to make a mistake. I'll do one step and I'll get one part of this. You're going to have to get the other part. So we need to eliminate one of these variables. And I would say eliminate the x. Why would you eliminate the x and not the y? Well, I would eliminate the x because when I look here, I've got a 6 and a 3. Now, 3 times 2 makes it a 6. So that one's going to cancel out right there. I probably wouldn't want to use the 6 and 4 because I'd have to use a 12. And I'd have to multiply it twice instead of just once. I'm trying to get by with just a minimal amount of work so I don't make mistakes. Because the more multiplications you do, the more likely you are to make a mistake. So we're going to eliminate x. And how do we do that? Well, we look at the least common denominator of 6 and 3. And 6 and 3, I can use a 6. Now, when I multiply the second row, I've got to make sure that I'm careful because one of these x's has to be positive and the other one has to be what? Negative. That way they cancel out. So I can't just multiply it by a 2. I've got to multiply it by a what? Negative 2. That way, the 6's can cancel. So distribute it through. And we'll see what we've got left here. So go ahead and distribute this through. And now we've got 6x minus 6y. That stays the same. Equals a negative 12. Distributing through, we get a minus 6x, which is what we want. We've got a negative 2 times 4y, that makes it a minus 8y. And commonly made mistake is students will forget the right-hand side. Negative and negative makes it a positive, and 34 times 2 should be a 68. So that's going to equal a 68 there. Add down. What happens is you get a 6 and an 8, both negative. They go together, and they give you a minus 14y. And we've got 68 and a minus 12. That makes it a positive 56. We'll divide by our negative 14. And that gives you y equals now 4. Negative 4. Right, watch your signs. Very, very careful with that. Okay. Positive over negative makes it negative. Now, how do we finish it? This is only half of it. We're not going to finish it for you, but what do you need to do? Okay, you need to use y equals negative 4 in one of the equations. To find x. Okay, so that's what you're going to want to do. You're going to want to plug in that y equals negative 4 into either one of these equations. Does it matter which one? No, I'd probably just plug it in here. Okay, so I plug it in there. Plug that negative 4 in, find it, and figure out what your x is, and then you write your answer as an ordered pair. And the answer is going to be, when you work it out, you've got the y, so you've got minus 4. So this is your y. We need our x, and you've got to complete it. So that's your answer. You're going to have to fill it in. You've got to put whatever number goes in this box. That's it. Is everyone okay with that one? Right? Not much to that one at all. Okay, 31 is the same process. And I'm going to work out half of 31. You can do the other half. So 31 is x plus 9y equals 63. And the other one is a minus 5x plus 10y equals 70. You'll also notice on your exam, in your practice final, your take-home final, did I give you any that have 3 variables and 3 unknown? 3 equations, 3 variables? No. 2 equations, 2 variables is all you're going to get. I'm not going to give you any 3x3s. We went over them, but I don't see any need to put them on the final. They're just too much work. They take too much time. Final exam is just checking the basic concepts. Do you know how to do a system of equations? Do you know what a square function looks like? Things like that. That's our focus. Not complicated questions, concept questions. Which variable do you think I would eliminate? Can someone tell me and have any idea which variable would I eliminate? X or Y? Which one do you think would be easier? X. Okay, someone said X. Now, why would you want to eliminate X and not eliminate Y? X just has a 5 and a 1, right? Now, what about Y? 9 and 10. Well, 9 and 10 have nothing in common, and you would have to use a common denominator of a 90. And that's going to be twice as much work as using a 5. Because I'm going to eliminate X again. And the least common denominator of 5 and that 1 there, because there's a 1 there, is 5. So there's really not much to do. The second equation is already done for us, but the top equation, what am I going to multiply it by? Oh, yeah, I'll get those recorded for you. What am I going to multiply the top row by? 5 or negative 5? Which one? Can anyone tell me which one I'd multiply it by? I would use a positive 5, right? Why would I use a positive and not a negative? Because you need to make sure they're opposites in signs, right? So easy enough, multiply it by a 5 and distribute it through. So when I distribute it through, that leaves me then with 5x. 5 times 9, that's a 45y. 5 times 63, we'll use a calculator here, and that's going to be 315. The next row stays the same. We're going to go ahead now and add down. What happens to the x's again? Okay, they're gone, right? 45 and 10, that makes it a 55y. And we've got a 315 and a 70. That's a 385. We'll divide by our 55. And we'll see what we're left with for the y. Y comes out to be 7. Now, you're going to have to finish this. So you're going to have to finish this. And what are you going to use? You're going to use y equals 7 in one of the equations. To find x. And what is your answer going to look like? As an ordered pair? Well, the answer is going to look similar to this. Blank, comma, 7. So whatever it is, whatever you find for the x, it goes in that blank. We write it as an ordered pair. You don't just leave the numbers there, write it as an ordered pair. Did we have any other questions to look at? Does that take care of all of them now? We've got plenty of time. So are there any other questions at all to look at? Give me a few minutes to make sure. I'll go ahead and pass out the sign-in sheet. But if we've got more questions, we can look at those. Any other questions to look at? Anything else? All right, well, then I'll let you out a few minutes early. I do have all of your homework that's been turned in, graded. So let me make sure I pass that back. Please pick up your graded homework over here. I will see everyone then when? Thursday morning at 8 o'clock. So make sure you're here Thursday morning at 8 o'clock. That is when our final exam is.